Part C of our regression presentation has to do with examples of linear regression, and we're going to present two of them to you to just give you an idea of some of the ways it can be used. Our first example is from the Challenger disaster in 1986, where the space shuttle blew up during launch because of the O-ring failures. The Morton Thiokol engineers who had designed the space shuttle knew that the O-rings were compromised because of low temperatures at the launch pad at the time of that launch, and they were arguing that the rocket shouldn't be launched. NASA was under extreme pressure to launch for a lot of political reasons. And so there was a conference call the night before, and in the long run, the engineers lost out, and NASA ended up launching anyway. One of the things that was not in the favor of the engineers was the graphical data that they used to try to defend their case. You see here a graph that was used to try and show that there was a correlation between O-ring failures in the booster rocket and the temperature at the time of launch. And here you see the number of O-ring failures on the left and the temperature of launch on the right. The data point on the far left represents the coldest launch that they ever did, which was at 53 degrees. Incidentally, the launch temperature that they were dealing with was around freezing at this point in time. But anyway, getting back to this situation, this graph did not seem to convince anyone at NASA or upper management at Morton Thiokol that there was a strong correlation between temperature and the number of O-ring failures, because if you fit a line to this data, it looks rather flat. However, what was left off of the previous graph were all of the launches where there were no O-ring failures. So where you see 0 O-ring failures, you'll notice that there were a lot of launches, but they were at higher temperatures. Now, let's fit a graph to this data. If we fit a linear regression line to this data and then extrapolate it back to 32 degrees, you'll see that it predicts 2 failures of O-rings. In other words, it is predicting a very large probability of an O-ring failure. Now this line really doesn't fit linear data. That is an issue that is a factor here, but still you can see that had they had the complete data set and used any kind of a fit to the data, they might have had a more convincing argument not to launch. For sake of completeness, let me show you this graph. Some scientists and statisticians were asked to predict the probability of failure using only data that was available before the launch. And you can see here a confidence interval around the probability of failure. And you can see that at 32 degrees, they were predicting a very high probability of failure. The next example of regression comes from some research I did where I surveyed executives in the automobile industry about their awareness and use of quality tools and statistical methods. So they were asked on a scale of 1 to 5 how aware they were of each of these quality tools and how much they felt they were being used within the company. One of the statistics I got from this was a total value for each one for both quality tools and statistical tools for both awareness and use. And that became some X variables that I used to predict something later on. Also on the survey, I asked some demographic questions, but there were two questions I asked related to quality and customer satisfaction. I asked the executives to estimate what they would say their customers would claim is the company or division's level of quality and customer satisfaction. One of the questions that I had was whether or not you could predict the quality or satisfaction level of a company based on the use of statistical methods and quality tools. And so here are the results of the correlations for those comparisons. And for item 12, quality, you'll notice there's fairly high bars on the right, and those are for the awareness and use of quality tools. And the 0.45 is the correlation between the use of quality tools and the quality level. And that's fairly high for this situation. And so the implication is that there could be some way to predict what the quality level of a company is based on its use of quality tools. On this slide, we have some further validation of the R value that was discussed on the previous slide. Here we have a box plot, and it shows for levels 3, 4, and 5 of quality. It shows what the totals were for the use of quality tools from the survey respondents. And although this relationship would have to be explored further, it does give some strength to the idea or concept that you might be able to predict quality level based on the use of quality tools.